So as we start Unit 2, our first section is on exponent properties. And so as we look at a radical, we need to remember that the little value, the r, is standing for the root or the index. And the xp part, this is called the radicand. And the little p part is our power. All right, and so we can rewrite this as a rational exponent. Instead of us writing it as a radical, we could also write it as a rational exponent. And so the power is going to be up top or in the numerator, and the index or the root is the denominator. So we just want to make sure that we remember that that's how that's going to go. So the little r, or the number that sits on the shelf of the radical, that's the denominator, and the power sits on top. So if there's not a power, then our power is a 1. So as we look at the fill in the blank part, it says the blank of the radical becomes the what? And so we're going to start with our power. So the power of the radical becomes the numerator of your fraction. And while the root or the index of the radical becomes the denominator. So remember our parts of a fraction. So numerator is the top, denominator is the bottom. If you need to remind yourself that, then write it on your notes. Okay, numerator is the top, denominator is the bottom. So the next part is just going to have you do that conversion, so where you're going to write it in the other form. So as I look at example 1, notice that our denominator is a 3, so we know that's going to sit on the shelf of the radical. And then notice that the whole entire 4r is in parentheses, so inside the radical, we want that whole entire 4r to be inside parentheses, and then our power is a 4. Now this can also be written a little bit different. If we wanted, we could do the same idea of putting it inside the radical, and then you could take the whole entire radical and raise it to the 4th. They mean the same thing. So you could see it either way, so just be aware of that. So now we have the radical, so now we want to go the other way. We want to write it as a rational exponent. So we're going to take the value that's under the radical, and I always put it in parentheses to be safe. So we're going to put it under the radical, and then the power is the top number, and the index or the root is our bottom number. So we write k to the 5/6. Again, example 3 is going back to a radical. So notice that, again, the denominator is a 4. That's what sits on the shelf because that's our root. Our value underneath the radical is just n. We can put it in parentheses if you want, but it's just one piece, so we don't usually need to. And then there's not a power. Well, there's a power of 1, so I don't necessarily have to write it. And then our last example, the 7v, we're writing it as a rational exponent, so we want our exponent to be a fraction. So whatever's under the radical, we're going to put in parentheses. And then the 4 is our power, so it's the numerator. And then 3 sits on the shelf, so it's our denominator. And we're just going to rewrite it. So you may have some problems just to practice the rewrite. Now we're going to use those rules to simplify some rational exponents. And so again, we talked about how a rational exponent is the same thing as taking a root of something. It's just a different way to write it. So if we look at like 8 to the 1/3, that is just a constant with a rational exponent. And so it's saying, well, how many of the same base can I multiply together to get me 8? And so we can either put that in our calculator to have this, because it's a number, or we can try to figure out how we can break that down. So if you think about 8, it breaks down to be like 2 times 4, 2 times 2. And so when you look at it, if it says 8 to the 1/3, we're taking the 1/3 root of it, or the third root. And so we have to have 3 of the same thing to come out. And so if I was looking at 8 to the 1/3 power, that's really the same thing as the cubed root of 8. And either way, we're going to get that's 2, because I've got 3 of a kind here. So remember, like back in 8th grade when you worked at these properties, you basically worked with just this left-hand side of the paper, where our properties our exponents were all integers. And so as you look, remember back we said that if the base was the same, we added the exponents. So if we look at our examples here, if we had z and z, my base is the same, so I'm going to add my exponents together. So 3 plus 8 is 11. If we look at a base of just a number, my base is still the same base. It's still going to stay 5. And then 6 plus negative 4 is 2. And if we can simplify it, great. If not, if it's too big, we just leave it. But in this case, 5 squared is 25. It's not a big deal. If I look at the next part, we have x to the a power divided by x to the b power. Again, the bases are the same. If your bases are the same and it's a division problem, then remember we subtract our powers. So if I was looking at our first example, they're both letters, letter m, or variable m. And so we've got m, and then we're going to go 10, subtract 3, which is 7. If we're looking at numbers, we're going, our base stays 4. We don't ever do anything with our base. And then we've got 8, subtract negative 3. So think about that. This is 8, subtract negative 3. And hopefully you're seeing like minusing a negative means that we're adding a positive. And so this really ends up being 4 to the 11th power. But notice how the base stays the same. When we're looking at a power raised to a power, again, we just multiply the powers. So if I'm looking at our first example, n is going to stay n. And then we're going 2 times 6. So this is 2 times 6, which makes n to the 12th. And then if it's a number, it's the same thing, 8, and then it's 3 times 4, which gives us 12. If it's a division problem and we're giving the power, we just give the power to both pieces. So in this case, that 3 is going to go into, or be multiplied by the 2 in the first, in the top, or the numerator, and to the 5 in the denominator. So this is going to go 3. 2 times 3 is 6. And then it's going to be x. 5 times 3 is 15. You just multiply the exponent powers. Remember, anything to the 0 power is 1. So if it's a number to the 0 power, it's 1. If it was a letter to the 0 power, it's still 1. If it's a whole bunch of stuff to the 0 power, still 1. And then the other thing we need to remember is that if we have a negative exponent, the way we make it positive is we move where it's at. So if it's a negative in the numerator, because remember this is, I can always put a 1 underneath. If that is a z negative 3 in the numerator, then I move it down to the denominator to make it positive. Or if it's a negative in the denominator, I move it up top to make it positive. So if I was looking at this one, 3 has a positive exponent. So it has a positive exponent of 1. So it's staying where it is. But the negative 4 in the bottom is going to come up to the top and become a positive 4, which really technically leaves a 1 in the denominator, but we just don't write it. Just like we don't really write it up here when it's z to the negative 3. All right, so that is those are all the exponent rules that you used or learned as an 8th grader. I'm going to stop the video here, and then in the next video, we'll talk about what we do when our exponents are actually fractions.